86 and 87. 86 picks up on page 560, deals with something fairly simple. We're talking about circles with chords, so being able to determine the length of a chord. This is specifically done whenever we have two chords that intersect each other. A chord is obviously a line segment that has its endpoints on the circle. In theorem 86-1, that's the only theorem that this lesson 86 holds, which is if two chords intersect in a circle, then the products of the chord segments are equal. In the diagram, AE, this segment right here, times EB is equal to the product of CE times ED. Okay, so we would multiply those separate segments, set them equal to each other, and solve for whatever missing length we might have. Okay, and so we'll look at problems here a little bit later on that are going to deal with how do I solve those particular problems. Okay, both with just pure numbers and sometimes with algebraically. Okay, when we get into lesson 87, this is about areas and ratios of similar figures. I feel like this is something that we've addressed earlier on in the year when we talk about it again today and bring it back to you. We want to call it polygons are similar if they have the same shape but a different size. And so when we talk about similar figures, the side lengths are proportional, the angles are congruent, correct? When we start talking about corresponding sides and angles, okay? Sides are proportional, angles are congruent. So this difference in size describes their scale factor to each other and can be written as a similarity ratio. Okay? For the square given down here below, the perimeter of the first square is 4a. A plus A plus A plus A is 4a. The second is 4b. B plus B plus B plus B is 4b. The ratio of their perimeters is 4a to 4b, and we can reduce that so that we see that our scale factor is a to b, whatever those numbers would be if we change that up. You know, it could be a is 1, b is 2, right? So I'd have a scale factor of 1 to 2, which means my b square is twice as big as my a square. Does that make sense? Okay, so if I knew that a represented 1, then my perimeter would be 4, correct? Yes? Yeah. Okay. Then if b equaled 2, then it would have a perimeter of 8. Okay? Do you see how the scale factor, which is 1 to 2, maintained its position into the perimeter? Had is the same as the scale factor. The ratio of perimeters will always be the same as the scale factor ratio. You get my point? Okay? Area will be a little bit different though. All right? Let's say, for instance, that we know that A is represented by 1, okay? Then what is the area of square A? 1, right? It has an area of 1. Well, let's say that B represents 2, okay? What's the area of square B? 4, okay? So what we noticed is that they had a scale factor of 1 to 2, right? And their perimeter had a ratio of 1 to 2, correct? All right, but when we start talking about areas, their areas in this case are b squared, so the ratio of their areas is a squared to b squared. These relationships are true of all similar polygons, and what we're going to see as we cover this next slide is if two similar figures have a scale factor of, in our case, a to b, then the ratio of the parameters is a to b, and the ratio of their areas is a squared to b squared. Okay? In this case, what you're going to see is that if I want to know what the ratio of their areas is, I'm going to square both of these things. What's 1 times 1? 1. And what's 2 squared? 4. Do we see how they have an area ratio of 1 to 4? Okay? So we take our scale factor and square both parts of that ratio. So if it had been 1 to, let's say this had been 1 and this had been 3, that would have given me an area of 1 and an area of 9, right? So the scale factor would have been 1 to 3. I would have taken the 1 and squared it. I would have taken the 3 and squared it. I still would have gotten 1 to 9. Okay? All right. let's get into some questions here. Hopefully these are things that you have. Does everybody have this document pulled up and ready to go? Okay. All right, so this is going to harken back to lesson 86. Okay. If I want to find out what x is, what am I going to do? What math am I going to get here? Okay, go back and look at lesson 86. Multiply. Multiply what, Erica? Okay, so let's look at a chord. This is a chord right here, correct? All right, so we're going to multiply the segments of that chord. What are the segments of that chord? No, not the letters of it, the segment lengths of it. What are the segment lengths of chord CD? 2 and 9. So we're saying 2 times 9 equals what? Austin, you had your hand up earlier. Equals what? 18? Yeah, I get that. No, but I want to know what. Okay, let's go back because I don't feel like either one, we didn't understand it whenever it came up, or we forgot it. All right, look at this. Determining chord length. A chord is a segment whose endpoints lie on a circle. If two chords intersect in a circle, then the products of the chord segments are equal. So what we said here is the length of AE times the length of EB is equal to the length of CE times the length of ED. All right, now let's go back. Okay. All right, 2 times 9 equals what? 3 times x. All right. Now let's simplify, but let's leave it over here. Okay, 2 times 9 is 18. 18 equals what? 3x. I want to solve for x. What am I going to do? Divide by 3. What does x equal? 6. Okay? X equals 6. Now, let's see. What else do they... All right. But they want to know what the chord length is, right? We already knew what the chord length of CD, right? We know that x equals 6, so that makes sense here. But in the end, let's scroll this back up. In the end, I still have to find the chord length. Okay? So what is the length of BA? 9. Because 3 plus 6 is 9. So BA, or AB, equals 9. And CD, we already knew, right? We already knew that that equaled what? What's CD equal? 11. All right, so that's everything that I need. Are we good there? Hopefully. All right, let's look at another one. I feel like this is maybe some of the easier stuff that we've looked at. All right, same rules apply here. All right, we want to solve for x, use the expression for the segment lengths to write and solve an equation for x. So they don't actually want the whole chord length, they just want to be able to solve for x. Darian, how do I set this up? 2x plus 3 times 4. Now, how am I going to represent that around both sets, right? All right, is equal to what? 10 times x, okay? All right, whenever I get over here, though, and I want to do this, what am I actually doing, Mariah? What am I doing with that 4? Multiplying. What's another word for the type of multiplication we're going to use there? Distribution. All right, so that means I'm multiplying 4 times 2x. What's 4 times 2x, class? 8x. Is that all I have to do? It's 8x plus 3? No, I have to multiply the 4 times the, and get 12. So I've got 8x plus 12 equals 10x. Again, we want to solve for x. Subtract 8x from both sides. Good. Okay, so that's giving me 12 equals 2x. Is that right? All right, what does x equal? X equals 6 again. I like to that there. All right, feeling a little bit better about it than we did first go around. Let's look at another one. Okay, number 3. Let's see, Miss IL. Tell me how to set this up. 2x, what? 2x plus 3? 2x plus 2 times 3 x plus 3 multiplied by 4. Okay? Nick, help me out here. What do I do on the left-hand side? 6x plus 6, good. What do you get on the right-hand side? Excellent. Okay. And let's clear that up there a little bit. Audrey, what would you do from here? Again, we want to solve for x. Give me at least one of your steps. Combine like terms. Can I combine 6x plus 6? Can I combine 4x plus 12? No. So in order to combine like terms, I'm going to have to move something from one side to the other, right? What would you move from one side to another? Okay, how would you move 4x over to the other side? Good. So subtract 4x. What am I subtracting it from over here? Okay. All right, what is 6x minus 4x? 6 minus 4? 2x. All right, so we got 2x. Now, what would you do after that? From both sides? All right, so we've got 2x equals what? 6. What does x equal? 3. Okay, so at this point, it's pretty well basic math stuff that we've done for a long, long time. Okay. All right, let's come down here. Now we're going to get into some lesson 68 things. All right. Let's see. Let's scroll this guy over. Okay, the polygons shown are similar. The length of a side of the smaller figure is 4 centimeters. The length of the corresponding side of the larger figure is 12 centimeters. If the perimeter of the larger figure is 48 centimeters, what is the perimeter of the smaller figure? Well, that we should be able to probably figure out. But does it say that these are squares? Does it? Let me see if it says it in there. It just says that they're figures. We can probably go ahead and guess at this, though, right? Yeah? All right. It says that the perimeter of the larger figure is 48. What's that going to tell me about each side? That they're all 12, right? Okay. If these are similar figures, what do I know the lengths of each side over here are going to be? 4. Okay, so what do I know the perimeter there to be? 16. There is another way to do this, though. Okay? We know that the ratio of their sides is 4 to 12, right? Can I reduce that fraction? Okay, what's that reduced to? 1/3, all right? So this is our scale factor, 1 to 3, right? So if I know the perimeter of this guy is 48, then I can simply cross multiply and divide, right? What's 1 times 48? 48. What's 48 divided by 3? 16, right? X equals 16, right? Now with a square, that's really easy. We could just say, oh, well, then each side has to be 4. 4 times 4 is 16. But we might be dealing with figures that aren't regular figures, okay? That's important. All right, let's keep moving. Now sometimes things get cut off on these questions. For instance, some of the lines of our figures get cut off. Okay, it should be a square, but it got cut off. The polygons shown are similar. If the figure of the larger figure, or if the area of the larger figure is 160 square inches and the similarity ratio is 2 to 8, what is the area of the smaller figure? Well, the similarity ratio is 2 to 8. Can I reduce the similarity ratio? 1/4, right? Okay. So we know the similarity ratio is 1/4. We know But in order to do this for the area, right, what do I need to do with 1/4? No. I need to basically find the ratio of their areas. How do I find the ratio of their areas based upon the scale factor? Square both numbers. Okay? So I'm going to square both of these things. So 1 times 1 is 1, right? What's 4 squared? 16. So the relationship of their areas is 1 to 16. Does that make sense? All right. So if I know that my ratio is 1/16, and I know that this guy has an area of 160, right? Now I cross multiply and divide. What's 1 times 160? Divided by 16? 10. Okay. So this box over here has an area of 10 inches squared. I'll go ahead and double check some of this. 10 inches squared. Okay. So your similarity ratio doesn't necessarily work for our area. Okay, we have to reduce it, and then we have to find our ratio of our areas. Okay. 6. A neighborhood map shows a park. The map has a scale of 2 to 725. What is the perimeter ratio of the park on the map to the actual park? What is the ratio of their areas? Okay, well, real simply, the ratio of their perimeters is our scale factor, right? So what is the ratio of their perimeters? 2 to 725, right? So we actually see that here and here, right? Okay, now if we want to know what the ratio of their areas is, what do I have to do with 2 over 725? Square it. Okay, so we're going to get 4 to what? What's 725 squared? Okay, 525,625. Okay, and we see how we get B for an answer there, correct? Okay, so the perimeter ratio is going to be the same as your scale factor. Your area ratio is your scale factor squared. All right, looks like we've got a total of 11 questions, just a few more left to go. Okay. All right, let's look at this one. In the similar figures below, the perimeter of the smaller figure is 30 feet. Okay? Determine the perimeter in feet of the larger shape. All right, well, what is my scale factor here? Can anybody tell me? What's 5x to 10x? What's 1 to 2, right? Okay? So my scale factor is 1 to 2. All right? The perimeter of the smaller figure is 30 feet. Where do I put that 30? Top or bottom? Top. Determine the perimeter in feet of the larger shape. So what do I do here? 2 times 30 is divided by, which is 60, right? So I should end up with 60 feet. Okay, 60 feet is my answer. We didn't really need, the x didn't really come into play because we saw the relationship of 5x to 10x. Those x's canceled out, left me with a scale factor of 1 to 2. Okay? All right. On a floor plan, a porch in the shape of a trapezoid has an area of 2.5 square feet. That's the floor plan. If the floor plan has a scale factor of 1 to 15, what will be the actual area in square feet of the porch when it is built? Okay, what do I need to do with 1 over 15? 1 over 15 is the scale factor, right? Square it. Okay, square each individual part. So that's 1 over what? 625? 225, right? 225. 1 to 225. Now, we're going to set this up. Now, 1 is representing my floor plan. 225 is the actual porch. Okay, so what am I going to do with this 2.5? Does it go on the top or the bottom? Does it represent my actual porch or does it represent my floor plan? Floor plan. So it goes up top, 2.5. Okay, so 225 times 2.5 divided by 1. 560.5, is that what you said? 562.5. Okay, 562.5. Let's see if that's right. Actually, I don't have an answer on that. Let's look. 562.5. Okay, and that should be in feet squared in terms of my answer. Okay? All right. Let's go back a touch here. Let's look at question number 9. What's my problem here? Number 9, what do I need to actually do first? You think I need to draw it? Okay. Yeah, that would probably help. Let's draw us a circle. It's pretty good. Okay. Let's see. We have chords QR and ST. So I'm going to draw a chord. I'm going to call it QR. I'm going to draw another chord. I'm going to call it ST. All right. Now notice that somehow U comes into play. Where is U at? In the middle. Okay, that's why drawing this becomes important. U are in the middle. Let's see, TU. Determine the length of TU, which means we are going to look for this length here. If QU equals 6 and RU equals 9 and SU equals 7. Let's see, Casey, I haven't called on you yet today. Can you tell me how to find X? What am I going to set up here? Lesson 86, if you need to go back and look at your notes in the book. What mathematical operation are we going to use, class? Multiplication. What things are we going to multiply? Class? No, don't tell me the numbers. What are we multiplying, though? Physically, what are we? Segments, right? So we're going to take the segments of an individual chord and multiply them by each other. So Casey, can you give me the numbers representing the segments of one chord? Like, let's say QR. What are the segments of QR? 6 and 9. So we're going to multiply 6 times 9, and we're going to set that equal to the product of the segments of the other chord. What are the segments of the other chord? 7 and X. So we're going to say 6 times 9 equals 7X. What's 6 times 9? So we're saying 54 equals 7X. So what would we do there to solve out the rest of that? Divide by 7. Okay. So X equals a couple of different ways to look at that. We could say 54 sevenths, or we could say, I think, 7 and 5 sevenths, something like that. I think they went with that. Or you could have given it probably as a decimal. The 7 and 5 sevenths is what they went with. Does that help you out there a little bit? Okay. Multiply those segments. All right, let's do another one with number 10. Number 10, In circle A, chords VW and XY intersect at Z. Suppose VZ is 4, WZ is in, XZ is 4 minus in, and YZ is 4. Write and solve an equation for in. So this even makes this a touch more complicated. Okay, let's kind of scoot down here and draw another one. Okay, let's see. Austin's going to help me out with this one. I'm going to call this VW. We're going to call this other one XY. Okay. Let's see. They intersect. What is this point here in the middle here? Z. All right. So we got VZ is 4. Let's see. WZ is in. XZ is 4 minus in. And we've got 4 down here. All right. Help me out here. What do I want to do? 4 in equals 4 in, or 4 minus in times 4. What would you do after that? Okay, so leave this guy over here. What do you get when you distribute that? 16 minus 4 in. Okay, what's your next step? Subtract 4 in? No. I've got 16 minus 4 in. I got 4 in over here. You want to get your 4 ins together, right? You want to. What'd you say? Add 4 in. Add 4 in to both sides. Okay, what's 4 in plus 4 in? You said what? 8 in. Okay, 8 in equals what? 16. What am I going to do there? 16 divided by 8. What does n equal? N equals 2. Okay? Is that a little easier than it looked to start with? Sure. Okay, just take these one step at a time. Do what you were taught. Come on. One of these days. Where are you going to... There we go. All right, 2 triangles shown below. This last question have a similarity ratio of 1 to 7. Determine the ratio of their areas and the area of the smaller triangle. Well, the first thing I can do is do what with 1 over 7? Square it, which is equal to what? 1 over 49, right? But what do I have to do next before I can solve the area of that smaller figure? I have to find the area of what? The large one. How do I find the area of this large triangle over here? Okay, so tell me what I'm plugging in there. Okay, so they're telling me 42 times 56 divided by 2. What's 42 times 56 divided by 2? 1,176. Where do I put that over here in this equation? On the bottom? So 1176. Is that correct? All right. So what am I going to do here to solve for the area of my smaller figure? Okay, they're telling me to take 1,176 and divide it by 49. What's that answer come out to? 24.06. And let's see. They round it to the nearest. Do they say to round it to the nearest? No, they don't. But we're just going to take it as 24 centimeters squared. Okay? What's that? Oh, so 24.06 was wrong? Oh, okay. So we didn't have to worry about that anyway then. Okay. All right. That's it. That's all I've got. So with the remaining, well, right around 10 minutes or so, you guys should and can be working on your homework. Oh, I'm sorry.